and homework number 12. Okay. All right, so the first theorem we're going to talk about, remember we learned the last class about these one factor theorem and the remainder theorem, and that if you are a factor, then your remainder is 0. If you are a 0, you can be written in a factor form. This is very important, okay? If you're a factor, then your remainder is 0. If you are a 0, your remainder, you are a factor. So that might be something that we want to write here on the side. You are a factor if you are a 0. Okay, important things to understand, because this first theorem is called the conjugate theorem. Conjugate 0 theorem. I'm just going to put that on my side here. All right, so it says if polynomial p of x has a 0, a plus bi, then the conjugate is also a 0 of p of x. Okay, we learned about i's and imaginary numbers way in the beginning. Well, now we're talking about them being zeros. So if I have an I and they tell me it's a 0, then I must also have its conjugate. And remember what a conjugate is. The conjugate would be a minus bi. They're interchangeable. So if I have a minus bi, my conjugate is a plus bi. I just change the sign in the middle. That would be the conjugate. Okay. So for our first example, we're going to find a polynomial of least degree. And that's how they're going to say it. Find a polynomial of least degree with a leading coefficient of 1 and zeros 5i and 4. Okay. Now, right off the bat, they're trying to trick you, because you're like, oh, 5i and 4, I only have 2 zeros. Okay, cool. But remember, if you have according to the conjugate 0 theorem, if you have 5i as your 0, then you also must have its conjugate. Well, remember, 5i is really 0 plus 5i, so its conjugate would be 0 minus 5i, or negative 5i. And then you also have 4. So there's my zeros. So my polynomial of least degree would be 1, 2, 3, degree 3. Because I don't want to make it a degree 7. I just want to make it a degree 3. Now again, if you are a 0, you are a factor. So we are trying to now find the polynomial that has these zeros. How do I do that? It's very easy. You just write them as factors, meaning the following. So if I have 1, 2, 3 zeros, I'm going to put 1, 2, 3 parentheses. I'm going to put x, x, x in front. And then minus, minus, minus. Remember x minus k from when we did the remainder theorem last time? Well, what do you think goes right here and right here and right here? Your zeros. So you put your minus 5i here. You put your minus negative 5i, which means plus 5i. And then you put your minus 4. These are the factors. This is how it's written in a factored form. This is how it's written as zeros. You change their sign, right? 5i minus 5i plus 5i. Plus 5i minus 5i. Minus 4 plus 4. Now, my math lab will not accept this. They don't want it in a factored form. They want it FOILed out. Okay, so you're going to have to FOIL. And I'll start with this one. The conjugate way of FOILing is super easy. To be honest with you, I'll show you what always happens. I'm going to do it the long way, but you'll see a pattern here. But if you do first times first, which is x squared, then outside, x times 5i would be 5ix. And then negative 5i inside, negative 5i times x is negative 5ix. And then last would be negative 5i times a positive 5i, which is negative 25i squared. But what is I squared? If you remember that from a couple chapters ago, I squared is -1. So what that does to this negative 25 is it turns it to be positive 25. And then look what's going to happen to the middles. They're always going to go out. Why are they going to go out? Because they're conjugates. The conjugates, the middle terms drop away. So these two terms FOIL together become x squared plus 25. Well, then what do I do about this guy over here? Well, now you're going to have to FOIL him times x minus 4. So now we'll FOIL that x squared times x cubed. X squared times a -4, negative 4x squared. 25 times x, and then last would be -100. Oops. This would be the polynomial of least degree that has zeros 5i, 4, and of course it's going to have -5i. And you're going to have to do this every time. Again, notice what I did first. I wrote this x minus, however many of them there were, x minus, and then I FOILed them out. And that's how you write your polynomials. So let's do another one. A little bit more challenging. Hopefully I have enough room here. Same thing. We're going to find a cubic polynomial with zeros 3 and 2 plus I. 3 and 2 plus I. So that means, again, I like to write this down. That means my zeros are 3. That's a good one. 2 plus I. And also its conjugate, 2 minus I. Okay? So the first step I do is I make however many zeros I have, and I write it in a factored form. So x minus, I'll put 3. Now, be careful on these two. Then this would be x minus, in parentheses, 2 plus I. There's a reason why I'm putting it like that. And then x minus, in parentheses, 2 minus I. Okay? Why am I doing that? Because that minus needs to be distributed. Some of you could probably skip this step because you'd be like, oh, I'll just distribute it up here, but this might just be something that you need to see. So this would really be x minus 3 times x minus 2 minus I times x minus 2 plus I. I just distributed that negative. Okay? Now, I like to start with the I conjugates because I know that a conjugate, things will go away. It'll be a nice, cleaner polynomial to work with rather than all these crazy I's. Now, this is a triple polynomial times another triple polynomial. So you're going to need to really be careful how to FOIL. So the way I do it is I do first times the first, first times the second, first times the third. So again, I'm working with these two. So x times the x squared. X times -2, -2x. X times positive ix. If you do it right, all those i's will go away. Now I'm going to do the -2 and I'm going to distribute it to all three of these things. -2 times x, -2x. I'm going to put it under here. -2 times -2 is +4. And then -2 times I is -2i. And now I'm going to do the negative I. Negative I times x, negative ix, look at that, they're going to go away. Negative I times a negative 2 is positive 2I. Negative I times a positive I, be careful, negative I times positive I is negative I squared. Okay, so let's see what that remains. My 2I and negative 2I go away. My ix and negative ix go away. I'm working down. I have x squared minus 4x. I have a 4. And then don't forget, I squared is negative 1. So negative I squared would be positive 1. So 1 plus 4 make 5. So that trinomial times that trinomial FOILed out becomes this. And then don't forget, you guys still got to multiply with x minus 3. So it's a lot of foiling. There's no, I wish I could tell you there's a short, cheat way of doing it, but you just got to do it. It won't get bad. I mean, you won't, it's tedious, but you get like very good at multiplying then. So x times x squared is x cubed. X times negative 4x is negative 4x squared. X times 5 is 5x. Now we do the negative 3, same thing. And I like to put my terms underneath each other, combining them. Negative 3 times x is negative 3x squared. Negative 3 times negative 4 is positive 12x. And negative 3 times 5 is negative 15. And that will give you the polynomial. I'm kind of running out of room, so I'll write it over here. X cubed minus 7x squared plus 17x minus 15. Here is your polynomial. It's cubic, which is what it asked for, with zeros of 3 and 2 plus I, and then of course 2 minus I, because it has to have its conjugate. That's the conjugate theorem. Okay, pretty easy, lots of foiling. Okay, let's find a polynomial of degree 3 with zeros. Oh yes, this one is a tricky one. I saw them do on your homework. Find a polynomial of degree 3 with zeros negative 3, negative 1, 4, and p of negative 2 equals 24. So this starts off the same way. They've given us zeros. We're to find the polynomial. We know that zeros can be written as factors. So we're going to start off like that. We're going to say, okay, p of x is x minus, there's 3 of them, x minus, x minus. I'm going to put my zeros into those blanks right there. So minus a negative 3 becomes plus 3. Minus a negative 1 becomes plus 1. And then minus 4. And then we're going to FOIL it. Nothing too terrible here. X squared plus 4x plus 3. I'm just going to safely assume you can FOIL that quickly. And now this is a triple and a binomial. And so you have to do the binomial each one. And then so then x times x squared is x cubed. X times 4x is 4x squared. X times 3 is 3x. And now I'll do the 4. Negative 4x squared. Negative 16x. And then negative 12. So that leaves me with x cubed, a minus 13x, and a minus 12. So you're saying, well, that's not bad. I figured it out. Well, what did they give me this for? Well, they're telling you that when you plug in negative 2 into this polynomial, you'll get out a 24, which means that there must be some coefficient, not 1, some coefficient in front of front of x cubed, and we'll call it a. So I'm going to actually go like this, and I'm going to put a little a right there. And we have to solve that. We have to find out what that a is. And that's where this comes into play. So this is saying when I plug in -2 in for x, -2 here and here, I should get out a 24. So this should be 24 if I put in a -2 everywhere I see an x. So -2 cubed minus 13 times -2, and then minus 12. So let's see, that would be -2 cubed is -8. -13 times -2 is positive 26, and then minus 12. And then what do we get that? 6? Yeah, 6. That's what we get. So 6a is on this side. 24 is on this side. So that means we had a leading coefficient of 4. Our a is 4. So now let's rewrite this polynomial that I have found. So I'm going to write, okay, so therefore P of x equals a is 4 times x cubed minus 13x minus 12. And I'm not sure if they're going to let you leave it like that or if they actually just want you to distribute the 4. So I'm just going to write it out distributed. 4x cubed minus 52x minus 48. And that's what that extra piece of information meant right here. P of -2 equals 24. They're saying that we know the y value, our P of x function, when we plug in -2 in, which means that we must have some kind of a in front. Okay, so you will definitely get a problem like that. Okay, and yet even more foiling. You thought we were done. No, there's a lot of foiling on this. Find a polynomial with a leading coefficient of 1. So that's nice. We already know that we don't have to do this a thing. With zeros. 4 plus square root of 5. 4 minus square root of 5. And 5. Okay, so same thing again. Just wanted to show you this one because it had some square roots in it, and I know everybody gets a little freaked out. They see a square root, they're like, please don't do this. Again, they've given you zeros, 3 of them. So I know it's going to be a polynomial of cubic. So I'm going to write x minus 4 plus square root of 5, x minus 4 minus root 5, and then thankfully x minus 5. Nice easy one there. And you do want to distribute that negative before you start foiling. So x minus 4 minus the square root of 5, x minus 4 plus the square root of 5, and x minus 5 is still there. Okay, so just like i's, because these are conjugates also, just like i's, the square roots, the radicals should drop away if we do it correctly, okay? So again, you've got a trinomial to FOIL with a trinomial. You want to take your time. Be slow. You don't have to be fast. Just x times x, x squared. X times -4, -4x. X times positive square root 5, square root 5x. Take your time. Now do the middle term. Middle to each one of these. -4x again. Positive 16, I'm going to put it over here. -4 times positive square root of 5 would be -4 square root of 5. And now I'm going to do this last term. Negative square root of 5 times x is negative square root of 5x. Look at what's going to cancel. Negative square root of 5 times a -4 is a positive 4 square root of 5. Look at that. And then a negative square root of 5 times a positive square root of 5, remember from when we did that, is the square root of 25, the negative square root of 25, or really it just pops itself out, so it becomes negative 5. So let's see. Those square roots, look at that, they cancel, which they should if you did it right. Then you're left with x squared minus 8x. And we got a 16 and a negative 5, which make 11. And then you think, oh, I'm done. No. And you still got x minus 5 over here to FOIL in. But see, you're getting so good at it now. I take the binomial and I distribute it into the trinomial. So x cubed negative x squared plus 11x minus 5x squared plus 40x minus 55. See, even with a headache, I can get this done if I take my time. X cubed minus 13x squared plus 51x minus 55. There you go. That is a polynomial leading coefficient 1, perfect, with the zeros of 4 plus square root of 5, 4 minus square root of 5, and then 5. Okay, just seeing what we have left here, where my halfway point is. Now, you will, I'm telling you this because I made up the midterm. You will have one of these on the midterm for sure, where I'm going to give you, you have to remember the conjugate theorem, so please don't forget about that. And know how to find that polynomial. You're just foiling it out. There's another theorem called the fundamental theorem of algebra. I'm sure you've been wondering your whole life why we've been doing algebra. Why have I done algebra? And this is why. Because every polynomial that you can think of, every polynomial function of degree 1, okay, it's got to at least have degree 1 or more, has at least one complex 0. Every polynomial function of degree 1 has at least one complex 0. That is why you studied algebra. Simply, you're like, why did I FOIL? Why did I factor? This is all why, just so you can find all the complex zeros. Amazing. Now, the number of zeros theorem states the following: that a polynomial of degree n has at most n distinct complex zeros. And we learned about that last week when we saw that, you know, zeros again are factored. We can write them as factors. They're also x-intercepts. And we noticed that they, the most they could have would be, if it was a degree 3, the most they could have is 3. They could still have 2. They could still have 1, but the most they could have would be 3. Same thing with the zeros theorem, that the most distinct complex zeros they could have would be n of them, okay? So how is this gonna, how are these two things gonna help us out? So they're gonna give you questions like this. Find all the complex zeros of p of x equals x cubed minus 8x squared plus 37x minus 50. Ooh, I was running out of room there. Given that 2 is a 0. Now that is really nice of them. They gave us a 0 being 2, so that is helpful. I know 2 will work inside of this polynomial. I also know that 2 is a factor of 0, which means that I should be able to synthetically divide by it and get myself down to a quadratic that I could use quadratic formula on, that I could solve, because I know how to solve quadratics. Quadratics are easy. You can complete the square, you can factor, you can do quadratic formula. So let's start with that 2 that they've given us. So we're going to find all the complex zeros. Complex, again, meaning i's or real numbers, the reals or the i's. So they've given us the polynomial. So we'll start by synthetically dividing. Synthetically divide by the 0 that they give you. And they gave us 2. So now we don't have to change its sign because it's not written in a factored form. So I'm just going to do 2. And remember how to synthetically divide. I do my upside down L. You put all your coefficients in correct descending order. So 1, -8, 37, and -50. And hopefully you got good at synthetic division. So we drop the first one, multiply, add, multiply, add. Ooh, that got me, 25. Multiply. Aha, I got a 0, which I should. If I did it right, I should get a 0. Okay, now, what I've now created is a decompressed polynomial right here that is now of degree 2. So this is x squared, this is x, and then plus 25. So now I have a quadratic, which is awesome because I know how to solve quadratics. I can either factor it, which looking at this right now, can you think of 2 numbers that multiply to 25 that make a 6? I only know 5 and 5, 25 and 1, but that won't make a 6. So if it's in a quadratic form, you can either factor or complete the square. I don't want to say complete the square, or quadratic formula. I think I wrote complete the square last year and everybody's like, no one completes the square. You should, it's not that hard. But quadratic formula is so much easier because most people know it. So let's do the quadratic formula here. So let's see if we remember it. This would be your A, your B, and your C. So negative B would be positive 6 plus or minus the square root of B squared, which is 36, minus 4 times A times 25. 4 times A times C, which would be 100 all over 2 times A. And then let's keep cleaning that up. 6 plus or minus the square root of would be negative 64. Negative 64 is a perfect I. So let's see, that'd be 6 plus or minus 8i divided by 2. And then that reduces to 3 plus or minus 4i. So let's go back and answer the question. Find all the complex zeros of this polynomial. Notice it's degree 3. So the most it's going to have is 3. Let's see if we found all 3 of them. Well, one of them was 2, because they told us 2 was a 0 and we synthetically divided. The other 2 are right in here. 3 plus 4i, and then 3 minus 4i. Notice there's that conjugate theorem coming up again, because if you got one, you must have both. Okay, so there's an example of finding complex zeros given one of them. All right, and then I'm going to do 2 more examples and then we'll take a break. So I know this is a lot of fun right now. I'm going to show you this one because this one's pretty quick and easy. And it says find all the complex zeros of p of x equals x to the fourth minus 7x cubed plus 18x squared. Ooh, I'm running out. Minus 22x plus 12. Hopefully you can read that. If you need me to read it again to you, I will. Given that 1 minus I is a 0. And I know what you're thinking to yourself. You're like, oh my golly, I don't want to write them all out. I don't either. So we're going to use our calculator. First thing I want you to notice is, again, it goes along with this number of zeros theorem, that a polynomial of degree n has the most amount of zeros n amount, okay? So when I look at this one, I'm like, oh my gosh, I got to find 4 zeros, 4 of them. Well, you really know 2 of them right now, don't you? I know 1 minus I is a 0. Therefore, I know its conjugate must also be a 0. 1 plus I. Okay, cool. I'm halfway there. Let's check real quick. Let's go on our calculator and check to see if maybe there's some real zeros that we can find. Like a real 0, like a 5 or a negative 12, something. Let's just look. So the way to do that is we're going to type this into the calculator, into y equals. So x to the fourth minus 7x to the third plus 18x squared minus 22x plus 12. Hopefully I didn't write it wrong. And you can graph it. I mean, you can look at the x-intercepts, but I'm going to kind of go to the table. So second window. Just want my table to start at 1, and then I'll go to second graph, which is the table. We've done this before. Well, look at there. If you are a 0, you are an x-intercept. So using my calculator, it's not cheating because I'm letting you use the calculator. Yeah, I've got 2, 0, 3, 0. I mean, and I can keep going up, but those 2, 0, 3, 0, those are x-intercepts. X-intercepts are real zeros. We found the complex ones. These are the real ones. So I have the 0, 2, and I have a 0, 3. There you go. I just found all my zeros because I knew that it was a polynomial 4. I have all 4 of them. So it wasn't that hard. If they asked you to write it in factor form, just so you know, how would you write it? P of x equals, you just put all of these in, x minus 2, x minus 3, x, and then change a sign, minus 1 plus I. And then x, change a sign, minus 1 minus I. And that would be a factor form. But these are all the zeros. And so it looked hard, it looked scary, but you can kind of go to your calculator and find those zeros to make it a little bit quicker and easier. All right. One more before our break. Flip this over. This one, it's a little bit crazy. I'm going to show you, though, on the calculator something. I don't remember where I left off with example 7. There we go. Use the 0 of 5 minus I to factor a polynomial x to the fourth minus 10x cubed plus 75x squared minus 490x plus 1274. And I'm going to have to use a whole side of paper just for this. But the first thing I would probably do is just go in my calculator and check to see if there's actually any real zeros, because I don't want to divide by that. Check for real zeros. I hate to tell you, there aren't. So when? But that would be a clue. So I know there's 4 of them. Goodness. And I'm just going to have to suck it up, and I'm going to have to do some synthetic division. But I've got ways to help you out with this, because that's why I'm a teacher. All right, so 5 minus I, we know for sure we're going to also have 5 plus I. Might as well write it down there just in case I'm going to have to divide by it. So you can synthetically divide, shockingly enough, with i's. Now you definitely want to make your L a little bit larger. And obviously your one coefficient is going to go here. I'm going to actually make some long boxes. You'll see why in a minute. -10 will go here. 75, thankfully it's all in order. -490. And then positive 1274. Okay, now you can do this. You always drop down. 1. 1 times 5 minus I is 5 minus I. Now you're saying to yourself, how do I combine -10 and 5 minus I? You know what to do. You combine your real part, -10, with the real part, 5. -10 and 5 make -5. And then you just put minus I. Now, if you were unsure about that, I'm going to just show you, because I know some of you are like, you haven't done math in a while, you get a little nervous. So if you go to your calculator right now, I'm sorry for my glare, and you go to mode, and if you look right here down where it says real and it says A plus BI, you can make your calculator add i's together and multiply i's together. So I changed it to A plus BI, and if you notice, if you have the newer calculators, it actually moves this up here next to the word radian, or maybe you have degree right here, it says A plus BI. So that if I type -10 plus, and then I had 5 minus, your I is right above the decimal point. It's hard for me to see mine, but it has an I scripted. And in order for me to get that I have to hit second. And it looks like that. And then hit enter. Look at that, -5 minus I, which is what we got. Well, now, again, what do you do from this point? You have to multiply these two. So I can do that in my calculator too. I can do it out by hand, but might as well use my calculator for that. So -5 minus I times 5 minus I. And it's -26. Look at that. You could FOIL it out, but I'm going to believe the calculator. You put that here. Now add them straight up and down, and that would be 49. And then do 49 times 5 minus I times 5 minus I is 245 minus 49I. 245 minus 49I. And then I'm going to add a -490 to that. And I get -245 minus 49I. And then I go to multiply these two together. And again, that's really big, so I'm just going to say multiply by 5 minus I. -1274. I know I did it right because I got a 0. Now, what did we just do? We now have to get this down even further, because this is now only a cubic. We have to go down to at least a quadratic. So what would be the other 0 that I would divide by? I would divide by the 5 plus I. I would synthetically divide by that. And I would do it into these because it's just much easier. Don't go back to this one. Go back into the decompressed one. So 1, -5 minus I, 49, and -245 minus 49I. Okay. This one's a little bit easier. So 1, usually when the first one's hardest, the second one is not so hard, surprisingly enough. So 1 times 5 plus I is 5 plus I. And then look what happens here. Look, ooh, bye-bye, bye-bye. 0, woohoo. Those are always good. And then 0 times 5 plus I is 0. Hey, buddy. I know things. Okay. 49 plus 0 is 49. And then 49 times 5 is 245. And 49 times I is 49I. Again, you can check it in the calculator. Bye-bye. That's 0. Woohoo! So what have I now established is an x squared polynomial, which is what I wanted. So I have x squared plus 49. And I want to solve this. Remember, once you get it to a quadratic, you either do, quadratic formula, or once it's a quadratic, you solve it like you would normally solve it. Well, x squared plus 49 equals 0. I can solve that actually without doing quadratic formula. I can just minus 49, take a square root. And whenever you take a square root, you include plus or minus. And this is a perfect imaginary number. So this would be plus or minus 7i. So let's look at what we have right now. We have plus or minus, we have our zeros would be positive 7i, negative 7i, 5 plus I, and 5 minus I. Those would be the zeros. But we got to go back up to the top and read what it said. Use the 0 to factor. Oy. It's not that bad. You just got to write it in a factored form. So you would write these in factors. So you'd write the following. Factored form. You'd write x minus 7i, x plus 7i. And then you write this x minus 5 minus I, minus 5 minus I, and then x minus 5 plus I. And that would be the factored form of that polynomial. So a little bit tricky. All right, I'm gonna take a break, give you a break. It's a lot and we're halfway through. We're a little bit more than halfway through, to be honest with you. So let's take about, 10 let's do 13 minutes. Let's come back at 7 o'clock and then I'll finish this lesson for you and then you can start the homework. Get something to drink. Something